Have you ever explored whether we're truly alone in the universe? Then again, have you thought about the possibility that there may be more to our reality than what we witness? Envision what might happen if the James Webb Telescope revealed that we live inside a black hole. That could change everything. As we dive deeper into this groundbreaking discovery, it could make you rethink everything you thought you knew about the universe. They're like something out of a nightmare. Sure, you may have seen them in sci-fi movies, but astonishingly, they're real and genuinely terrifying. Experts have shown that black holes in space are thought to contain massive amounts of matter compacted into a tiny region. Imagine a star much larger than the Sun compressed into a sphere the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape it. Researchers have been fascinated by black holes for decades. They've studied objects in space so massive and dense that they trap light. The most remarkable ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star collapses, it leaves behind a dense core. If this core's mass is several times greater than the Sun's, gravity overwhelms everything, leading to the creation of a black hole. Detecting black holes is no easy task because they don't emit light. However, researchers have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it pulls the matter toward it in a process called accretion. Furthermore, when a star gets too close to a black hole, it can be destroyed, emitting X-rays in the process. Black holes also have a tremendous impact on their surroundings. They can consume nearby stars, release powerful radiation, and even influence the formation of new stars, sometimes slowing it down in certain regions. Where do black holes come from? Imagine stars once massive and powerful meeting their violent end in a spectacular event known as a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life in a supernova explosion. Smaller stars, when they die, transform into neutron stars, extremely dense but not dense enough to trap light. However, if a star's mass is several times that of our Sun, it collapses under its gravitational force, forming a black hole. During these collapses, something peculiar happens near their surfaces. Time itself begins to behave strangely. From the perspective of someone far away, time appears to slow down near the event horizon, the final boundary before anything falls into a black hole. Occasionally, when two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, they create a colossal phenomenon that defies comprehension. Scientists have been studying the sizes of these titanic phenomena for years. Black holes come in two main sizes, large and small. There's a mysterious allure surrounding them that we can't fully unravel. However, small is relative when it comes to black holes. Large black holes, the remnants of giant stars, can be 10 to 20 times the size of the Sun. There may be as many as 10 million to a billion of them in the Milky Way alone, an astounding number of black holes capable of consuming anything in their path. But wait, there's something even more massive. Supermassive black holes are on the extreme end of the spectrum. They are millions, if not billions, of times larger than the Sun. These exist at the centers of giant galaxies, including our own Milky Way. It's like an enormous dead space pulling everything toward it. Renowned physicist Stephen Hawking spent much of his life studying black holes. His discussions were always captivating, but some of his theories couldn't be confirmed due to the lack of advanced equipment. However, there's hope on the horizon. A single scientific instrument is making a huge difference: the James Webb Space Telescope, JWST. This is no ordinary telescope. It's an engineering marvel and a testament to human creativity. While we've launched other space telescopes before and they've done well, this powerhouse is truly extraordinary. The JWST makes the Hubble Space Telescope, our previous workhorse, seem like a mere speck in the universe. This astronomical marvel cost a staggering $10 billion and took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring it to life, along with contributions from over 300 universities. Such an ambitious undertaking comes with risk. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Since its launch, the JWST has achieved remarkable milestones. It traveled over 1 million miles to its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sunshield and giant primary mirror, both of which had to be folded to fit inside the launch vehicle. Now, after NASA adjusted and calibrated it, the telescope is almost ready for full operation. One of the most inspiring moments was when NASA announced that the telescope had captured its first images of starlight. The first image was of a star called HD 84406, resulting in a mosaic of 18 bright spots from the light captured by the 18 mirror segments. NASA later released another stunning image of HD 84406 with the 18 images combined into a hexagonal arrangement. Once the observatory fully aligns its primary mirror segments, it will begin stacking images into one clear view. Thanks to its advanced technology, the JWST will help scientists study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed in a period called the Epoch of Reionization. The JWST will also assist in discovering exoplanets, observing their atmospheres, and determining their conditions to predict whether they might be habitable. Moreover, it will help scientists understand the organization of matter on a large scale and how galaxies evolved over billions of years. Its high-level infrared sensors can recognize the faintest light from the farthest reaches of the universe, uncovering peculiarities that were previously undetectable. One of its key missions is to peer back to the universe's earliest days by observing the first galaxies that formed after the Big Bang. The JWST will provide insights into how matter began to organize itself, ultimately leading to the complex structures we see today. This investigation will help scientists understand the origins of stars, galaxies, and even the building blocks of life. The telescope's powerful instruments are also designed to study exoplanets, planets outside our solar system. It will analyze their atmospheres, searching for chemical markers that could indicate the presence of life. Imagine the implications of finding a planet with water, oxygen, or other biomarkers. It could fundamentally change our understanding of life's potential in the universe. Furthermore, the JWST will examine mysterious objects like quasars and pulsars, as well as phenomena such as dark matter and dark energy, which remain some of the greatest puzzles in astronomy. These studies could unravel the secrets of the universe's expansion and its ultimate fate. Yet, the telescope's potential extends beyond astronomy. By studying the composition of distant planets and moons, it could guide future missions in the search for habitable worlds. It's not just about exploring the past, it's about predicting humanity's future. Whether or not we are alone in the universe has captivated us for centuries. The JWST could not only bring us closer to answering that question, but also redefine our place in the cosmos. If it finds evidence of other civilizations or even microbial life, it would be one of the most significant discoveries in history. And then there's the idea of whether we might be living inside a black hole. This idea, once considered science fiction, has gained traction among some physicists. They speculate that our universe might be a bubble within a larger structure, essentially inside a black hole. The JWST's ability to observe the universe on a grand scale could provide clues to this mind-bending hypothesis. The James Webb Space Telescope represents the pinnacle of human creativity and curiosity. It is a symbol of what we can achieve when we dare to dream big and work together. Its journey has only just begun, and the discoveries it will unveil may reshape our understanding of the universe and ourselves for generations to come. As of now, scientists have been exploring intriguing findings. Complex molecules called polycyclic aromatic hydrocarbons, PAHs, lurking around colossal supermassive black holes in 3 powerful galaxies. These carbon-based particles with ring-like structures are the Goth offspring of the universe. They're everywhere, from distant galaxies to comets and even in our own solar system. They're not just fascinating because they could be the building blocks of life, but also because they help astronomers trace star formation. When ultraviolet radiation hits these PAHs, they fluoresce and emit infrared light, a signal detectable by the JWST's mid-infrared instrument. This is often a sign that there are some hot, young stars nearby. However, there's a twist. Astrophysicist Isel Garcia Bernard from Oxford University decided to focus on 3 unique galaxies, NGC 6552, NGC 7031-9, and the renowned Stephan's Quintet, located millions of light-years away in the depths of space. What Garcia Bernard found was astonishing. In the central regions dominated by massive black holes, he detected a wealth of PAHs.